Good morning, guys. Welcome back to another video. We're talking about notes 9.1.3. It's a pretty quick set of notes just talking about quadratic equations, the different ways that we know how to solve them, and a little bit more practice with the quadratic formula. So in notes 9.1.3, it says, what if the equation is not in standard form? We know that the standard form for an equation, quadratic equation, is ax squared plus bx plus c is equal to 0. What if an equation is not in this form? Then how can you solve it? That is the quick thing we'll talk about today. So let's just jump in. 9-24 says, for this quadratic equation, can you solve it using the zero product property? So if we're solving using the zero product property, that means that we're doing it with factoring. So let's dive right in. We know that factoring is this box with the diamond or the x. We know the top is multiplication and the bottom is addition. So what goes on the bottom left of the box? Well, it's 6x squared. What goes in the top right of the box? It's the negative 10. How about the top of the x? 6x squared times negative 10 is negative 60x squared. What goes in the bottom, the middle term? This positive 11x. So now can I find two numbers that multiply to negative 60 and add up to 11? In this case, I can. You can pause the video and try some for yourself if you'd like. Otherwise, if you're just following along, how about 15 and negative 4? 15 times negative 4 is negative 60. 15 plus negative 4 is 11. Let's give an x to each. If you remember, now that we have these two things, it doesn't matter where we put them. We can put 15x here or vice versa. I'm going to put it this way, 15x, and then here, negative 4x. Let's find some GCFs. What are the GCFs going this way of 15x and negative 10? Well, the biggest thing that goes into 15 and 10 is 5. And because 15x is positive, the 5 would be positive as well. Why can't you take any x's? Because negative 10 doesn't have any. How about 6x squared and negative 4x? Well, the biggest thing that goes into 6 and 4 is 2. Notice they both share an x, so I can take out an x as well. I'm going to go positive 2x for the GCF because 6x squared is also positive. How about going down this way? What's the GCF of 6 and 15? Well, that would be 3. They both have an x that they share, so I can take out an x as a GCF as well. How about a GCF going down this way of negative 10 and negative 4x? Well, that would be 2. I can't take any x's because negative 10 doesn't have any. And I am going to go 3x minus 2 or negative 2 because negative 4x is negative. So then if I wanted to write this as a product, then I know I can use length times width. This is not anything new. So I have 2x plus 5 times 3x minus 2. And I set it equal to 0. Well, now the zero product property says that if 2x plus 5 times 3x minus 2 is 0, if two things multiply to 0, then one of them, or both of them, have to be 0. So the first one I have is if this times this equals 0, then it could be the case that 2x plus 5 is equal to 0. But does it have to be that 2x plus 5 is 0? No. The second one you have is it could be 3x minus 2. Could be the one that's equal to 0. So then just solve it. How can I get x by itself? Well, number one, first thing I can do is subtract 5. So now I have 2x equals negative 5. The 2 is next to x. This implies multiplication. What gets rid of multiplication? Division. Divide both sides by 2. X equals negative 5 halves. There's one solution. How would you solve number 2? Well, to get rid of a minus 2, you could add 2. So I have 3x equals positive 2. Well, 3 is next to x being multiplied. So to get rid of it, I'll divide both sides by 3. X is equal to 2/3. So my two solutions using factoring and the zero product property are negative 5 halves and positive 2/3. Okay, in part B, it says solve the same equation but use the quadratic formula. Okay, so this is what the whole last section was about. Start with x equals. We can also list off the a, b, and c values if you think that helps. So going back to this equation, what part of that is the a value? Well, the a value would be 6. What would the b value be? It would be 11. And the c value would be negative 10. So when we start doing the quadratic formula with x equals, what's the opposite of b? Well, b is 11. What's the opposite of 11? Negative 11. Now we have plus minus, make a big square root. Inside the square root, b squared. So we'll start with 11 squared minus 4 times the a value, which is 6, times the c value, which is negative 10. All over 2 times the a value, which is 2 times 6. All right, guys, let's simplify it and see what happens. So then I have negative 11 plus minus, big square roots, What is 11 squared, or 11 times 11? It's 121. Negative 4 times 6 is negative 24. Negative 24 times negative 10 is positive 240. All over 2 times 6, which is 12. All right, simplify a little bit more. A negative 11 plus minus, what's 121 plus 240? It's 361, all over 12. What is the square root of 361? You could find it in your calculator. This is going to be 19, all over 12. So now our two calculations, we have to do plus and minus. So let's start with the plus version. If I start with plus, what is negative 11 plus 19? Well, negative 11 plus 19 is 8, all over 12. Let's reduce it. The GCF of 8 and 12 is 4. 4 goes into 8 2 times. 4 goes into 12 3 times. So x equals 2/3 is one of our solutions, which does match one of the solutions that we had in part A. So I did the negative 11 plus 19. Now let's do the negative 11 minus 19. So what is negative 11 minus 19? Well, that would be negative 30, all over 12. What's the GCF of 30 and 12? It would be 6. So how many times does 6 go into negative 30? It goes negative 5 times. How many times does 6 go into 12? It goes 2 times. So the other solution I get from the quadratic formula is negative 5/2. So notice how if I did it with the zero product property in factoring, I got negative 5/2 and 2/3. If I do it with the quadratic formula, I also get negative 5/2 and 2/3. Just like we talked about in the last video, it doesn't matter if you do factoring or the quadratic formula, you should get the same answer. So that's kind of nice. Some people like the quadratic formula because it's just plugging in the things that you know. Some people like factoring because we've done so much of it and they're more familiar with the diamond. It's really up to you. So did the solutions from part A and B match? If not, why not? Yes, they did match. Factoring and the quadratic formula produce the same solution. All right, guys. So we only have one more example today. So today, kind of a very fast video. We're going to do 9-25, and then I'm going to talk about the math notes real quick. So if you're okay with that, then I'm going to fold this over so we have some space to work, as always. And let's see what happens. So here it says quadratic formula, or solving directly. We're going to try these actually all with the quadratic formula and just kind of show you what they would look like if they're not in standard form. So again, as the notes from the previous lesson demonstrated, the quadratic formula can solve anything in the form ax squared plus bx plus c equals 0, where a does not equal 0. What if the equation is not in standard form? What if terms are missing? So how would you do the quadratic formula if something wasn't in the form ax squared plus bx plus c, or if a term is missing? So let's think about these questions as we solve these equations down here. So notice the first one. I have 4x squared minus 121. So what if I did like I've been doing for the last several questions with quadratic formula and just list off what I know? I want to list off A, B, and C. Is there an A value? Well, yeah, there's a number in front of x squared. The A value would be 4. But is there a B value? In this case, notice the middle term, the ax squared plus bx plus c, the middle term is missing. So if it's missing, then you're going to put in a 0 for it. How about the C value? Well, the C value is still here. It's 121, but it's also negative. So I need negative 121. So now if I go with the quadratic formula, I just know that if a term is missing, I have to put in a 0 for it. So we have x equals, we start with the opposite of b. So b is 0. What's the opposite of 0? Well, it's a little bit of a trick question. 0 is the only number that doesn't have an opposite because 0 doesn't have a sign. So the opposite of b is still technically 0. Plus minus big square roots. Inside of here, b squared, so 0 squared, minus 4 times the a value, which is 4, times the c value, which is negative 121, all over 2 times the a value, which is 2 times 4. So then what we have is 0 plus minus. Let's go find out what's underneath this square root. So if you want, you can do it entirely with a calculator. Maybe that will save a little bit of time. So we'll go calculator. Let's go 0 squared minus 4 parentheses 4 parentheses negative 121. And again, if you're using a graphing calculator, the parentheses are right above the 8 and the 9. So that's the calculation underneath the square root. We notice it's 1,936. So on my paper, square root's 1,936 all over 2 times 4, which on the bottom will just be 8. So let's keep rolling. So then I have x equals 0 plus or minus. So what is the square root? So we go to square root. 1,936 is 44. So then I have this right here, all over and then 8. So we have two calculations. Remember, one positive and one negative. So what's 0 plus 44? Well, that's 44. So we have 44 over 8. What's greatest common factor would be 4. 4 goes into 44 11 times. 4 goes into 8 2 times. So in that case, one of my solutions is x equals 11 over 2. What would my other solution be? I can do x equals, well, I did 0 plus 44. How about 0 minus 44? 0 minus 44 is negative 44 over 8. The GCF is still 4, but 4 goes into negative 44 negative 11 times, and 4 goes into 8 2 times. So my solutions for part A are positive 11 over 2 and negative 11 over 2. All right, guys, so how about B? Notice B is 2x squared minus 2 minus 3x. So is it in standard form, ax squared plus bx plus c? Well, the first term is 2x squared. I agree with that. That's the biggest exponent. But then what's the next biggest exponent out of negative 2 and negative 3x? Well, it should be negative 3x because that's negative 3x to the first. And then the negative 2 should go at the end, and it should be equal to 0. So all we have to do, guys, is just rearrange it. So then what's the a value? It's 2. What's the b value? Negative 3. What's the c value? Negative 2. So let's break this up so I don't run into myself. Kind of box it up a little bit. Okay, so then here we go. X equals, what's the opposite of b? Well, b is negative 3, so the opposite would be positive 3. Plus minus, big square roots, inside of here, b squared, negative 3 squared, minus 4 times the a value, which is 2, times the c value, which is negative 2, all over 2 times the a value, which is 2. All right, so then if you want, we can say 3 plus minus, big square roots, all over 2 times 2, which is 4. So let's go find what's underneath that square root, right? So go back to our calculator, in parentheses, negative 3 squared, that's just what's happening underneath the square root here, minus 4 times 2, in parentheses, times negative 2. So just like you see it on the paper there, underneath the square roots, that's what we're typing into the calculator. And if you do, you get 25. Most people are okay with the square root of 25. What is the square root of 25? Well, it's 5, so I have 3 plus or minus 5 all over 4. So let's do our two calculations. What's the first one? How about the plus? 3 plus 5 is 8 divided by the 4 on the bottom. 8 divided by 4 is 2. So one of my solutions is x equals 2. How about the other one? Well, if I did 3 plus, now let's do 3 minus. What is 3 minus 5? Well, that's negative 2 divided by 4. The GCF of 2 and 4 is 2. 2 goes into negative 2, negative 1 times. 2 goes into 4 2 times. So my other solution will be negative 1/2. So my two solutions for part B are positive 2 and negative 1/2. All right, guys, so let's keep going. How about C? Is it in standard form? Well, notice standard form for the equation is supposed to be equal to 0. And here I have 15x squared minus 165x minus 630. I'm going to get a piece of tape just so I can tape down my paper so it doesn't keep folding up. So then the first thing we should do is try to get in standard form. Why would you want to get in standard form? Because if you get in standard form, then you can find out what A, B, and C are. And if you know what A, B, and C are, then you can use the quadratic formula. All right, so let's see if we can do it. So the first things first is, do I have the first term in standard form? Well, it looks like we do. We have 15x squared, so we can write that. So 15x squared. The next term should be the x term, so that's the negative 165. But then how can I get it equal to 0? Well, here I have negative 630. So what I can do is I can add 630 to this side. I can add 630 to this side. I can't combine anything because nothing is a like term, but I can write it as positive 630. And now these two cancel out and you're equal to 0. So if I have that, I can find out what A, B, and C are. So I'll give myself some space to do this. So I can say A is 15, B is the negative 165, and C is 630. So notice these numbers are a lot bigger than the numbers we saw in A and B. So let's do it. So we can say x equals opposite of B. What's the opposite of negative 165? Well, it's positive 165 plus minus big square roots 165, negative 165 squared, minus 4 times the a value, which is 15, times the c value, which is 630, all over 2 times the a value, which is 2 times 15. Okay, so then maybe we should find out what this big square root is. So we have 165 plus minus square root. Let's go find out. So definitely don't expect you to have this one without a calculator. So then we can go in parentheses negative 165. We can square it, minus 4 in parentheses times 15 times 630, just like what we have on the paper. And you get something like this. All right, guys. So then if you have that, then you said negative 165 squared minus 4 times 15 times 630. You get something like negative 10,575 all over 2 times 15, which is 30. But now what is the square root of negative 10,575? If you try to go into the calculator and take a square root of negative 10,575, it's going to tell you a non-real answer. Why is it a non-real answer? Well, you can't take the square root of negative numbers. So what does that mean about the solutions? You can say that there are no solutions. What are solutions? Well, they're x-intercepts. So in this case, you can say there are no x-intercepts, which indirectly means there are no solutions to this equation. This parabola is not going to hit the x-axis. So that one will be considered done. All right, guys. So last one here. D, 36x squared plus 25 is equal to 60x. First thing, I want to get it equal to 0. So how could I get rid of a positive 60x? Well, I can subtract 60x. I'll subtract 60x on the other side. Can I subtract 60x from 36x squared or 25? No. So this will become 36x squared. The next biggest one in order is negative 60x. I still have this positive 25. And now 60x and negative 60x cancel off, so there is 0. So now let's just say what we have. We have A as 36, we have B as negative 60, we have C as 25. So let's do the quadratic formula. X equals, what is the opposite of B? Well, B is negative 60. The opposite of negative 60 is positive 60. Plus minus, let's go big square roots. Inside of here we have B squared, so negative 60 squared minus 4 times the A value, which is 36, times the C value, which is 25. Okay, all over 2 times the A value, which is 36. So let's do it. How about we go into the calculator? Let's go negative 60 squared. And then we have minus 4 times 36 times 25. And we have 0. So then we have x equals 60 plus or minus the square root of 0 all over 2 times 36, which is 72. What is the square root of 0? Well, it's just 0. So then if we finish our calculations, we have 60 plus 0 and 60 minus 0. But notice that if you add 0 or subtract 0, it won't change 60. So we'll have 60 all over 72. We'll find a GCF for 60 and 72. What is the GCF for 60 and 72? Well, it actually turns out that 12 can go into both of them. In this case, how many times does 12 go into 60? It goes 5 times. How many times does 12 go into 72? It goes 6 times. Again, you can use a calculator if that's not something you can do in your head. So that means that x is equal to 5/6. There's only one solution for this one because, like what we said, adding 0 to 60, subtracting 0 to 60 will not change 60. So you're just going to get 60 over 72, which reduces to 5/6. So what if I were to ask you in A, how many times does this parabola hit the x-axis? Well, it hits twice because there are 2 solutions. How many times does the parabola in B hit the x-axis? Twice, because there's 2 solutions. How many times does the parabola in C hit the x-axis? Well, it doesn't because there are no x-intercepts. And how many times does the parabola in D hit the x-axis? Well, just once because there's only one solution. All right, guys, so that's how you can handle things that are not in standard form. Basically, what you do is you get them into standard form. So that is my suggestion. If you don't get something right away in the form ax squared plus bx plus c, then try to bring everything over to the left side, get the equation equal to 0, and then put it in standard form. Why would you want to put it in standard form? Because then you can say what a, b, and c are, and then you can use the quadratic formula. Okay, on the second sheet of paper, you'll see 9-26. This question is optional, so if you want to try it, I'll leave that totally up to you. You can try it and see how it goes. But what I'd like to do is quickly talk about the math notes. So in the math notes, it just highlights the two big methods that we currently have for solving quadratic equations, and it gives us some quick examples. So how about example 1? We have 3x squared plus x minus 14, and then we want to solve it using the zero product property. So remember, zero product property means to use factoring. So that if you wanted to see where they're getting their work from, you can set up the box, you can set up your x with the multiplying and the adding, and then find out. Here it says for the solution, factor the quadratic so that you can write it as a product, 3x plus 7 and x minus 2 is equal to 0. So if you wanted to, you could do that. So that's going to be using this factoring method. The zero product property states that if the product of two things is 0, then at least one of them must be 0. So if 3x plus 7 times x minus 2 is 0, that means either 3x plus 7 is 0 or x minus 2 is equal to 0. If you were to solve x minus 2 equals 0, you can add the 2 over. One solution would be x equals 2. If you were going to solve 3x plus 7 equals 0, you'd have to subtract over the 7 and then divide by 3. It would be negative 7/3. So in that case, your two solutions, negative 7/3 and positive 2. Again, it's the math notes, so they're doing all the work for us, just making sure that we understand what's going on. So how about an example 2? Same equation, but let's use the quadratic formula. So again, first thing, is it in standard form? It is. So the first thing that they do is list off what A, B, and C are. They notice that A is 3, B is positive 1. Again, if you don't see it there, it's a positive 1. It's not 0, because 0x means that it wouldn't be there at all. And then C is negative 14. So substitute those values in, and then find out what you have. So in this case, they notice B is positive 1, so the opposite's negative 1, plus square root B squared minus 4AC. Then they did a separate calculation for the second one, negative 1 minus the square root of B squared minus 4AC. They crunched in their calculator and found out underneath the square root, simplified each answer, and got x equals 2 and x equals negative 7/3. Which in this case match up the solutions for example 1 that they have here in the math notes. So notice negative 7/3 and positive 2. So the big message here at the end with the math notes is that regardless if you do things with the zero product property and factoring or with the quadratic formula, you should get the same answer. So it really is up to you and preference. Do you understand how to do factoring in the zero product property? There's nothing wrong with it. But if you like just rearranging in standard form, picking off A, B, and C and plugging them in and finding what that calculation gives you, then the quadratic formula is a very good option. All right, guys, that completes the video for today. If you could go ahead and complete the assignment and submit it as usual, I would really appreciate it. Thanks for watching the video, and have a great day.